Imagine a creature no bigger than a crow, covered head to tail in glossy black feathers, with not 2 wings but 4, launching itself from a tree branch 125 million years ago, gliding silently through a Cretaceous forest. This is not a bird, not exactly, and it's not quite a dinosaur in the way you'd picture one either. This is Microraptor, one of the strangest, smallest, and most scientifically important dinosaurs ever discovered. A creature so small it could perch in your hand, yet so significant that it rewrote our understanding of how flight itself evolved. Today, we're digging into the complete story of Microraptor. The real fossils, the real scientists who uncovered it, the forgery scandal that nearly buried the truth, the dating methods that prove its age, and the ongoing scientific debate over whether this tiny dinosaur could truly fly. The name Microraptor comes from Greek and Latin roots, micro meaning small and raptor meaning one who seizes. True to its name, this was a tiny predator, measuring only around 77 centimeters, roughly 2.5 feet from snout to tail, and weighing barely a kilogram, about as much as a small house cat. Microraptor lived during the early Cretaceous period, somewhere between 125 and 120 million years ago, in what is now Liaoning province in northeastern China. Despite its small size, Microraptor belongs to the Dromaeosaurid family, the same group of sharp-clawed, sickle-toed predators that includes the far more famous Velociraptor. But Microraptor had something Velociraptor never had: wings. Not 1 pair, but 2. Long, flight-capable feathers extended from both its arms and its legs, a genuinely 4-winged body plan, unlike almost anything else known in the animal kingdom, living or extinct. For over a century, paleontologists assumed that as dinosaurs evolved toward flight, feathers developed first on the arms, gradually forming a single pair of wings, the same setup birds have today. Microraptor shattered that assumption. When paleontologist Xu Xing first examined a well-preserved specimen in 2003, he noticed something nobody expected. Long, asymmetrical flight feathers were not only present on the forelimbs, but also on the hind legs as well, running down the thighs and shins all the way to the feet. This was unmistakably a 4-winged animal. This discovery forced scientists to rethink the evolution of flight entirely. Some researchers proposed that Microraptor used its 4 wings in a biplane configuration, the hind wings positioned below and slightly behind the forewings, gliding from tree to tree in a manner similar to a flying squirrel, but using feathers instead of skin membranes. Others have gone further, suggesting Microraptor wasn't just gliding, it may have been capable of genuine powered flapping flight, launching from low branches and covering real distances through the dense, gymnosperm forested landscape it called home. This debate is still very much alive today, and we'll return to it later in this documentary.
So, how do scientists know Microraptor lived roughly 125 to 120 million years ago, and not some other point in Earth's history? The story starts with stratigraphy, the study of rock layers. Microraptor fossils come from a sequence of rock formations in Liaoning province, collectively known as the Jehol group, which includes the Yishan Formation and, sitting just above it, the Jiufreitong Formation, where the vast majority of Microraptor specimens have been found. Because sediment builds up over time in a predictable, layered order, fossils found deeper in this sequence are generally older than those found closer to the surface. But stratigraphy alone only tells us relative age, older versus younger. To get an actual number, scientists turn to radiometric dating. The Jehol group is famous among geologists for its interbedded volcanic ash layers, thin bands of ash from ancient volcanic eruptions that settled into the lake beds alongside the animal and plant remains. These ash layers are rich in radioactive isotopes, most notably in minerals like zircon, which scientists can date using uranium-lead dating, as well as argon-argon dating techniques on volcanic minerals. Because radioactive decay happens at a fixed, known rate, measuring the ratio of parent-to-daughter isotopes in these layers tells scientists almost exactly when that layer was deposited. Since the ash settled in direct contact with the fossil-bearing sediment, this gives an unusually precise date for the fossils found within it, placing Microraptor firmly in the Aptian stage of the early Cretaceous, roughly 125 to 120 million years ago. This is also part of why the Jehol Biota, the entire ancient ecosystem preserved in these rocks, including Microraptor, early birds, feathered dinosaurs, and pterosaurs, is considered one of the most precisely dated fossil deposits anywhere in the world. Microraptor's story begins not in a formal museum expedition, but in the fields of Liaoning province in northeastern China, where local farmers had been unearthing extraordinarily well-preserved fossils from fine-grained lake sediments in the 1990s. This region would go on to produce some of the most important feathered dinosaur discoveries in history. In the year 2000, paleontologist Xu Xing and colleagues described the first Microraptor specimens, naming the species Microraptor jiaoianus, based on fossils recovered from these Liaoning quarries. But the fossils kept coming, some beautifully preserved, others incomplete, missing skulls or limbs pieced together from a scattering of specimens collected across several years. Then, in 2003, everything changed. Xu Xing gained access to a remarkably complete specimen, one that preserved something no one had confirmed before: long, pennaceous flight feathers, not just on the arms, but running the entire length of the hind legs. Publishing in the journal Nature, Xu and his colleagues named this new species Microraptor gui and coined the now famous description, a genuine four-winged dinosaur. Since then, dozens of Microraptor specimens have been recovered from the Jiufotong Formation, making it one of the best represented non-avian dinosaurs in the fossil record, an extraordinary level of completeness rarely seen in animals this small and this old. But Microraptor's story has a darker chapter, one that became one of the infamous scandals in modern paleontology. Before Microraptor was properly named and described, a specimen surfaced that had been illegally excavated in China and smuggled out of the country for private sale. In 1999, this fossil was unveiled to enormous fanfare by a major American publication as Archaeoraptor, heralded as a genuine missing link between dinosaurs and birds, with a bird-like body and a long dinosaurian tail. There was just one problem: it was fake. Not a hoax invented from nothing, but something arguably worse, a composite. Fossil dealers had glued together the front half of an early bird with the tail of an entirely different feathered dinosaur, creating a chimera that never existed in nature. It was Xu Xing himself who exposed the fraud. Examining the fossil closely and later matching it to a genuine counterslab recovered separately, Xu determined that the tail section didn't belong to the bird-like body at all. It belonged to a small, previously unknown dromaeosaurid dinosaur. That dromaeosaur would go on to be formally recognized as part of the Microraptor story, turning an embarrassing scientific scandal into the foundation of one of the most important dinosaur discoveries of the era. It's a powerful reminder that even in modern paleontology,
verifying a fossil's authenticity and its complete undisturbed context in the rock is just as important as the discovery itself. Today, paleontologists continue to recover new Microraptor specimens from the same fine-grained, ash-rich lake sediments of Liaoning that first yielded this remarkable dinosaur. Unlike the massive bones of giants like Triceratops or Tyrannosaurus, Microraptor fossils are delicate, compressed almost flat within thin sheets of shale, meaning excavation and preparation require extraordinary precision. Preparators work under microscopes using fine needles and delicate air tools to expose bone and feather impressions without destroying the very details that make these fossils so scientifically valuable. The faint, feather-like traces preserved as carbon films across the surrounding rock. Because the volcanic ash that blanketed this ancient ecosystem preserved soft tissue in extraordinary detail, some Microraptor specimens even preserve stomach contents, fish scales, small mammal bones, and lizard remains, giving scientists rare, direct evidence of exactly what this animal was eating shortly before it died. Once a Microraptor fossil is fully prepared, museums face a unique challenge. How do you display an animal this small in a way that conveys its true scientific importance? Unlike a towering sauropod or a fearsome tyrannosaur skeleton, Microraptor doesn't dominate a room through sheer size. Its significance lies in the intricate feathered details preserved across the slab. To help visitors truly understand what this creature looked like in life, many museums now pair the original fossil slab with a fleshed-out reconstruction, a full-scale feathered model, wings extended, showing the animal exactly as it may have appeared gliding through a Cretaceous forest. These reconstructions sit alongside casts of the fossils and comparative skeletal material from other Jehol Biota animals, letting visitors see, side by side, just how this tiny four-winged predator fit into a much larger and more diverse Cretaceous ecosystem than most people realize. Here's a question that once seemed impossible to answer. What color was Microraptor? For most of paleontology's history, the color of dinosaur skin and feathers was pure speculation, educated guesswork based on modern animals. But in 2012, a team of researchers led by Guo Li, working with scientists from the American Museum of Natural History and the University of Texas, changed that entirely. Examining a remarkably preserved Microraptor specimen under a scanning electron microscope, the team identified fossilized melanosomes, microscopic pigment-containing structures preserved within the ancient feathers themselves. By comparing the shape, size, and stacking pattern of these melanosomes to a large database collected from living birds, the researchers could statistically predict the original feather color. The result? Microraptor was almost entirely black, with a glossy, iridescent blue-black sheen, remarkably similar to the plumage of a modern crow or starling. This made Microraptor the first non-avian dinosaur ever confirmed to have had iridescent coloring, and it strongly suggested that its elaborate tail feathers and long head plumes weren't just for flight. They may have played a role in visual display, courtship, and species recognition, much like the flashy feathers of many birds today. Even after more than 20 decades of study, one central question about Microraptor remains genuinely unresolved. Could it actually fly, or could it only glide? Some researchers argue Microraptor's skeletal proportions, including its shoulder structure and limb ratios, suggest it was built for controlled gliding between trees, not sustained flapping flight. Under this model, Microraptor would have used its 4 feathered limbs the way a flying squirrel uses its skin membrane, catching air to control descent and distance rather than generating true lift through wing beats. Other scientists disagree, pointing to feather asymmetry and shoulder joint mobility that closely resembles features seen in birds capable of powered flight, suggesting Microraptor may have been capable of at least short bursts of true flapping flight, launching from low perches or even level ground. The debate matters because Microraptor sits right at a pivotal moment in the evolution of flight, and depending on which theory holds true, it changes our entire understanding of whether powered flight in the dinosaur bird lineage evolved once or multiple times independently. Microraptor may never have carried the size or ferocity of a Tyrannosaurus, and it will never headline a blockbuster film the way Triceratops or Velociraptor do. But in scientific terms, few dinosaurs have reshaped our understanding of evolution quite as profoundly. From a scandal-plagued forged fossil smuggled out of China to a genuine scientific breakthrough naming the first confirmed 4-winged dinosaur, to a groundbreaking study revealing its true iridescent black plumage, Microraptor's story is a reminder that the biggest scientific revelations don't always come from the biggest animals. Every new specimen pulled from the shale of Liaoneng adds another piece to a story that continues to change how we understand the origin of flight itself. If you enjoyed diving into the real fossils, the real scientists, and the real controversies behind Microraptor, make sure to hit that subscribe button, because we uncover a new fossil story like this every single week. Drop a comment below. Do you think Microraptor was a true flyer or a skilled glider? Let's debate it down there. And if you want to see more deep dives like this one into feathered dinosaurs, famous fossil scandals, and the scientists racing to piece together prehistoric life, hit that like button, and I'll see you in the next one.